Hi class, how are you doing? I hope everyone's well. We are in Unit 10 and doing 10.1 Law of Sines, which if you recall was sine A over its opposite side length is equal to the sine B over its opposite side length is equal to the sine C over its opposite side length. Okay. Now, one of the things I didn't go over in the first lesson was that this only happens, or you could only use it in certain cases. And I did sort of go over it, but I didn't specify. If I have an angle side and an angle, then it's useful because you can have opposite side over opposite angle over opposite side over opposite angle. So you have to sine of opposite angle anyway. Or it can be helpful if you have an angle, and then a side. And that allows you to set up everything because you have to have an angle opposite a side. You have to have at least one of those ratios and then another angle so you know the side. And in this case you had you can find that third angle. You'd have angle, sine of the angle over the side is equal to the sine of the angle over finding another side. So you have to have a specific setup in order to use the law of sines. If you're looking at example 2 with me, we'll go ahead and proceed with that. Now, we know this angle is 21 degrees. This angle is 119 degrees. And we have this side measure 7. So this is an angle side scenario. So we can use the sine law of sines. All right, so we're going to do sine of 21 over its opposite side, which is 7, is equal to the sine of 119 over its opposite side, which is x. All right, so that's how we set it up. We note that sine of the angle over the opposite side is equal to the sine of the angle over the opposite side. Now, if we cross multiply, we have x times the sine of 21 is equal to 7 times the sine of 119. Now, remember to write the number before the sine function so that it keeps the numbers away from each other and they don't get confused. All right, so you cross multiply yourself for x. X in this case is being multiplied by the sine of 21. So you're going to divide by the sine of 21, right? In order to have x equals. And if we divide one side by the sine of 21, we must divide the other side by the sine of 21. So we have x is equal to 7 times the sine of 119 over the sine of 21 degrees. All right, now yesterday I didn't do this, but today I am going to. I'm going to try to put the calculator up so you can see what to place in the calculator. I'm hoping this doesn't. So if I do this, I can hold it and it won't glare. All right, so I would get a fraction in your calculator. Hopefully you can run and grab a calculator like the one we use in class all the time. And then you can do 7 times the sine of 119 on the top over the sine of 21. And that way you won't mess anything up and everything will be right when you're done. That is 17.084. All right, that's approximately what x will be. You had to approximate because you rounded. All right, and that's what we do. How exciting is that? That's going to give you x. It says to the nearest tenth, so it would actually be 17.1. Approximately. Okay. All right. I'm going to see. Ooh, this does give me new colors. I want that color. Okay. Example 3. Excuse me. Okay, so the next example 3, we have an angle. Is it going to give me that color? So we have an angle, and a side. Angle, side. Okay, so here is our but our actual ratio that we have. We have an angle that's 64, so the sine is 64 across from the side we know is 32. So that gives us our complete ratio with numbers in it. And then the other one is 45. So sine 45 over, we don't have that side right there. That's not one of the sides. We have this side right here, which is across from this angle right here. So what we'll have to do is come up with that angle. We can't come up with side measures because the side measures are unlimited. We don't know side measures. However, the angle measures are limited. They have to add to 180. So if we add 64 plus 45, okay, so 64 plus 45, we get 109. And 180 minus 109 is 71. So we know this one is 71 degrees. And we have to have the side across from the angle and the angle across from the side. So sine 45 is not going to work for us. We're going to have to use 71 instead. So 71, and that's going to be across from our x. That's the angle we must use, otherwise we'll get it wrong. So we have sine 64, which is across from 32, and sine 71, which is across from x. And then we cross multiply. So x times the sine of 64 is equal to 32 times the sine of 71. When we cross multiply. And of course, x is being multiplied by the sine of 64, so we want to divide by the sine of 64. So those divide away, and we're left with x is equal to 32 sine 71 over the sine of 64. All right. Gosh, something in my throat. It's 32 sine 71 over sine, you know what, I probably ought to put this in the calculator again. Where's my, I never know where my little, there it is. So we have 32 sine of 71 over, of course I covered it up, was it sine 64? So sine 64. All right, we'll just plug it in the calculator using that. So 33.7. So x is approximately 33.7. All right, pretty cool. Okay, the next one, let's see. This x is across from 110, so we're good with it. This, however, this 19 is across from this angle, which we don't know. So in order to find that, we need to take 110 and add 41, so that's 151, and then subtract that from 180. So 180 minus 151 is 29, so that means this angle is 29, and that's the one across from the 19, so that's the one we needed. But luckily we had two of the other angles, so we could sum and add them together and subtract from 180 to get that side length. So we're going to do, what is this, sine of 29 over 19 is equal to sine of 110, which is the one across from the x. So we have to make sure we get the ones across from each other. All right, cross multiplying, we have x times the sine of 29 degrees is equal to 19 times the sine of 110 degrees. And then we divide by sine of 29. So it's being multiplied by the x, which we're solving for. So we have x is equal to 19 sine 110 over sine of 29, which is approximately, I'm going to show you another trick here on the calculator, which might help you, except I keep covering up what I need to do. So 19 sine 110. So I arrowed up. I'm going to arrow up. Hopefully you can see that this is highlighted. I arrowed up, highlighted it, and hit enter. And then all I have to do is change the angles, 29, 110, and then 19. So 19 sine 110 divided by sine 29 is 36.83. So I think we're doing partials. 36.8, just to 1 degree, right? 1/10, 1 decimal place. All right, so there you have it. Isn't that exciting? Okay, we still have some examples to do, and before you can get to your homework, and we'll do as many as we can, and then I'm going to have to make a third video. So Kevin, Adam, and Dan are passing a hockey puck. All right, so this is the picture that you see, and you're going to use this picture for examples 5 and 6. So example 5 says, how far is Kevin from Adam? So Kevin from Adam is right there. Okay. Now I can almost guarantee I'm going to need to know that other angle. I'm going to just figure that out real quick. 71 plus 86 is 157. So that's 157. And 180 minus 157 is 23. So I'm just going to write that in. I'm guaranteed I'm going to need it at some point. So I'm just going to get all the angles. And also I need it right now because Kevin and Adam is across from that angle. That distance is across from the sine 23, the 23 degree angle. All right, now this angle 86 and 25 is my complete ratio. So that's awesome. We're going to use that. Sine 86 divided by 25 is going to equal our sine of our 23, just found angle, which is across from x, so over x. Okay, that will be what we set up for that. X times the sine of 86 is equal to 25 times the sine of 23 when you cross multiply, and then solve by dividing by a sine of 86. And we can plug that in the calculator. 25 sine 23 over sine 86. And we're going to do an approximate. So I'm going to go back up again and extract my other template and make sure I have 25 sine 23 over sine 86. And that is approximately 9.8. All right, and that's going to be feet. So this is 9.8 feet. All right, and then how far is Dan from Kevin? So now we're going to look for this distance here. That's across from the 71. So sine 86 over 25, which is our normal one, the one that we have all the measures for, is equal to the sine of 71 over y. Okay, and that's what we'll use. I think I can get this all done before and not have to do a secondary video. Y sine 86 is equal to 25 sine 71. All right, and divide by sine of 86, which divide away, and we have y is 25 sine 71 degrees over sine of 86, which is approximately, again, I'm going to steal my other thing, which I only have to change this time the 71 degrees because I already have 25 sine 7 from before and sine 86 from before. So it's approximately 23.7 feet. All right, so they're pretty far away, 23.7 feet. All right, Adam and Kevin are the closest. Hopefully they'll be the most successful with their passing the hockey puck. All right, good luck. Have fun with 10-1. If you have any questions, email me. I'll set up a Google Meet for later this week. Thanks, bye.